remains constant. Speed will be constant. The particle is at position 1. After some time, let it arrive here. So then what is the velocity here? Will be direct. Vector. So look at there's a change in direction. Go back to the kinematics definition. Particle is said to be accelerated when there is a change in speed or change in direction. Look at the particle as it moves from 1 to 2. It will take some time, no, to arrive here, and it will also undergo angular displacement, say theta. Let this be radius. So it takes some time. So is it direction of motion change? There should be some acceleration. And according to the basic definition of kinematics, acceleration, how you define? Delta V bar by delta T. What is delta V bar? Delta V bar final minus initial. We define like this. So let's go for the vector diagram. V1 bar is like this. This is the V1 bar. What about V2 bar? V2 bar is somewhere like this. Then what we want? V2 bar minus V1 bar. So V2 bar minus V1 bar. This is V2 bar. Minus V1 bar. Minus V1 bar vector. This vector, I'll end up like this. Then how delta V bar? The delta V bar should be directed like this. Look at now this acceleration, this particular acceleration, how it will be directed. I think I'll give this due to change in direction. No, I'll call this as normal, AN only. How this AN bar will be along delta V bar. Will I agree? Basic definitions. So this is called a centripetal acceleration. I will be directed along the change in direction of velocity. So roughly from vector diagram, I'm able to predict what the delta, how the delta V bar is somewhere. You can see in this direction. Got this? So somewhere it will be directed towards center. This will be. So here I'll show that delta V bar, or say the centripetal acceleration will be directed. So therefore, what is this AN? Centripetal acceleration, and I will be directed to be always directed towards the center and tangential are normal to the tangential velocity. So why AN should be towards center? This one. So this particular AN, I'll give a name. Rather than radial acceleration, I'll call it as centripetal acceleration. Why it is? This acceleration, it is due to change in direction of motion, not due to change in speed. It's purely due to change in direction of motion. So due to change in direction of motion, there'll be one acceleration, they'll be directed towards center. That is what we call centripetal. Sir, how much? Already I brought this view. Can you remember how much I brought it? Omega square r, no? Can we bring it by vector method? By something triangle. So what is delta V? Okay, let's do one thing. Delta V will calculate. So what is delta V? Vector subtraction. So what is the angle? Angle, it was theta, no? So how to bring this theta? What is the angle between V1 bar and V2 bar if this is theta? V2 bar is somewhere here, no? V2 bar was somewhere here. So way to indicate this theta in this diagram? Okay, we'll do one thing. Take help of this. Some rough diagram I'll give. How to bring that one. So this we know V2 bar. and this we know V bar, and this is theta. So bring like this. This is theta, 90 minus theta, this will be theta. Okay, got this one, no? So this is theta. Will agree this analysis. This should be theta, no? This should be. So from here, what happen? This I'll call theta. So what is this angle will be? 180 minus theta. So what is the angle between V2 bar and V1 bar? Minus V1 bar. 180 minus theta. So this will be root of V2 square, V1 square, 2 V2 V1. Angle between V2 bar and minus V1 bar is how much? 180 minus theta. And V2 equal to V1 as we know. So this will be V square plus V square minus 2V square cos theta. So V square will come outside. 2 into 1 minus cos theta. 1 minus cos theta from trigonometry, anything can be right. And this will be only V into 2 sine square theta by 2. Sine square theta, can I write 1 minus cos 2 theta by 2? Okay, 2 will be there. One more. I'm just taking help of the trigonometry, that one. Sine square theta 1 minus cos 2 theta by 2. So sine square theta by 2. Can you write it as 1 minus cos theta? So 1 minus cos theta, what you can write it as? 2 sine square theta by 2. So 2 into 2, this will come outside. 2v sine theta by 2. Theta very small. Sine theta by 2 will become this one. Delta v. So this should be equal to 2v theta by 2. 2 get cancelled. So what we end up, delta v is equal to v theta. Theta is angle. So now I'll put delta v by delta t. So v by delta t. I'll bring it to the corner. I'm showing by several methods. In different books, they're given different method, no? So that I'm introducing all the things. So delta v by delta t, this I'll call it as centripetal acceleration. V into theta by delta t. This will become angular velocity. Okay, look at now again. What is this is like a v only, no? So what is v equal to? R omega, or according to this, v equal to r omega. Or you can also write it as v into omega what again, v by r. Centripetal acceleration. Okay, now it's very clear. Huh? Why do this acceleration is? Just due to change in direction of motion only. This is first method what I shown, directly I brought the formula. Still students what happen, they don't get idea what is centripetal acceleration. Because the idea of centripetal acceleration is very important for dynamics of circular motion. Okay, I started here. The particle moves with a constant speed in a circular path. Then I said that there is one acceleration called as centripetal acceleration, and that will be directed towards the center. And definitely we'll assume it's circular motion r constant. This one. So sir, how you can say that that acceleration be directed towards center? Okay, already I have give proof. Can you remember here? We have here, you look at this. There is a one acceleration which which is directed. There's one acceleration which is directed towards the center. This is central acceleration. If v constant, then omega constant, alpha 0. If r constant, these quantities will be 0. So then only if a particle moves with a constant speed, there will be one acceleration called as Ramchandra Reddy. Don't unmute it. Huh?
Okay, sir.
Okay, got this. There's a mathematical. Straight away we'll get it here. So you never get an idea that, sir, why this acceleration? Sir, we brought mathematics. I'm all of you. So that's why I'm just brought this. So there's a general idea what students should have. Let's focus separately that one. Let's focus separately. Here also I brought the thing. If a speed constant, there'll be one acceleration called as centripetal. Why do this acceleration? Anybody asks? We don't have any specific reason, no? So here what happened, I am just giving that information with the help of a separate discussion. Let me assume that the particle moves with a constant speed. It's a uniform circular motion. Once again, I'm bringing back uniform. So in uniform circular motion, will there be will there be any acceleration? Yes, there'll be acceleration. What is that acceleration? Called as central acceleration. And how it be directed? Towards center. So here is what we have, everything vector proof, and the expression also we brought it here. This is very important. First thing, if you are finding very difficult, leave it, no problem. But this is very important. So therefore, now shall we make up the problem into two parts: uniform, non-uniform circular motion. In uniform circular motion, speed of particle constant, and how that central acceleration will be directed towards the center. Non-uniform circular motion, what will happen? There'll be two accelerations. One, centripetal acceleration, other tangential acceleration. Tangential acceleration is due to change in speed. Centripetal acceleration is due to change in direction of motion. So once again, I'll bring back that non-uniform circular motion. So in non-uniform circular motion, earlier we discussed uniform circular motion. Now let me introduce to that's why in non-uniform circular motion, what will happen to speed of particle? It constantly varies. Let me call r, no problem. That is r means it's constant. The speed of particle, it varies. Then v of t, I'll write it. Velocity, you can see is varying, speed is varying. Then what about the accelerations? It is going to have two accelerations. One centripetal, another is tangential. So what is the tangential? Tangential is purely due to if I'm writing v theta, no, let it write v theta by r. If you are if you are not interested with this symbol a theta, you can remove it. Let me remove this theta. This is a central acceleration. Why? This is due to change in direction of motion. Then again, due to change in speed, a theta equal to dv by dt. This is a tangential acceleration. The resultant acceleration how it will be directed? Somewhere like this. And this total acceleration vector makes an angle with the tangential velocity. So what is tan beta? Tan beta should be equal to an by a tangential. An equal to how much? V square r. This is dv by, I'll write one more. So dv by dt, what you can write it as? This you can also write it as r into, because v, what you can write it as? R into omega. So r d omega by dt. So this is r alpha. Okay, got this one. So this we can write it as r alpha. So this will become v square by r square alpha. Now look at that v, the beta, is it constant or variable? It, as the v constant increases, so and alpha is constant, so beta is going to increase here. The total acceleration vector S, it will have different directions. This is due to what? This is due to what? Change in speed. This is due to what? Change in direction of motion. I want total acceleration. Already we have discussed. Once again, I'm putting it. An square plus a theta square. What is the angle made by total acceleration vector with tangential velocity given by this particular formula. So we are going to come across numericals of what kind? Uniform, non-uniform circular motion. Again, in non-uniform circular motion, again you can put in two parts: alpha constant, alpha variable. If alpha constant, then again we'll make up a problem. If alpha is constant, means constant angular acceleration. Constant angular acceleration. Then, so what is alpha? So alpha we know d omega by dt. So further d omega alpha dt. Let me integrate 0 at t equals 0 omega naught. So therefore omega minus omega naught alpha t. So somewhere this equation is similar to the things what you came across, no? Equations of motion. Then further d omega by dt, I can write it as alpha constant. So this is the angular displacement 0 to t, 0 to t. So this will be theta omega naught dt. So this will become omega naught t plus this angular displacement. Then straight away you can write it alpha is equal to d omega by dt. You can also write it as d theta you can also write if alpha as a function of d omega by dt, or you can also write in this form. So this will become alpha d theta omega d omega 0 to theta omega naught by omega. So this will be alpha theta so value of this will be so I think somewhere similar to the linear equations, no? S equal to ut plus half at square, v equal to u plus at, then v square minus u square equal to 2as. In place of that, there it was linear motion. This is for angular motion. So how alpha, omega, theta, if they are related when alpha is constant. These are called like equations of curvilinear motion or equation for circular motion. Equations of motion for circular motion. So these are the formulas which, if you remember, will be easy. When this formula is applicable, when alpha is constant, a strict condition, only when alpha is constant. Only when alpha is variable, these are applicable. And so if alpha is also variable, then I'll go for integration, like what we did in kinematics. So what are the types of numericals you are going to come across? V constant, alpha constant, alpha variable, and alpha what can vary with what? Can vary with any of the quantity. Then we are going to take help of the integration. So this is about the basic our circular motion what we had. Now I'm telling this one of all very important centripetal acceleration. This acceleration is purely due to change in direction of motion. There are two accelerations are there. One centripetal, other tangential. Centripetal acceleration is due to change in direction of motion. Sir, how you can say? I'm giving enough proof. You can see this mathematics. This is very important. Of all what all I discussed now, this is very important. How that AN will be directed towards center is from the vector subtraction is what I explained. Earlier I did by mathematics. Here vector subtraction. non-uniform, uniform circular motion. So here there are two things are there for you: uniform, non-uniform. Non-uniform, both accelerations will be the tangential, centripetal acceleration. Uniform circular motion, only central acceleration. So then you should say, sir, uniform means no acceleration. As the direction is varying, no. Because of that, the central acceleration will be directed towards center, and you can see that. And how will be directed? Always towards center. You see. So don't think that as the particle moves, the an will be here only. When particle is here, where an will be here. When particle is here, an will be here. When particle is here, an is there. So is it advisable to go for unit vector? No. Better what happen? Better take help of the tangential unit vector and radial unit, because there are these directions are very important, no, rather than I cap j cap. Because when particle is here, how an will be in third quadrant. When particle is here, fourth quadrant. So therefore, whenever circular motion comes, what is the best thing? It is better to go for the radial direction and tangential direction, because all the quantities will be directed there only. Okay, still some like a few more things. There's just a mathematical background. So if you last what I discussed, that one, so that you have to remember. Let R be the constant. Only if R varies, I'll mention, because all problems you have to assume R to be constant. Okay, let's the no one more mathematical way I'll bring it. This is what A normal, no.